Hello there. Today we'll be doing redundant connections. This will be using a different type of algorithm for this type of problem. We'll be using a union find suggested by Leetcode. So what's going on here is that we have this example with 3 edges and 3 nodes. The number of nodes will match the number of edges, so there will always be a cycle. And we're trying to find the last item, last occurrence that causes the cycle, which is here 2 and 3. What union find is that we're going to create this root-like structure. So we have currently root is currently 1, 2's current root is 2, and 3's current root is 3. And all items have a rank of 1. And what's going on is that what we're going to do is going to, I guess, union the roots together. What does that mean? So look at 1 and 2. So what we're gonna do to find that last item is we're gonna do union find, and that means we're creating a tree with a parent. So let's say this is the one tree, and we're gonna find out who's gonna be the top parent, and with the top parent, if 2 items point to that parent, the same parent, that means that's the occurrence where the node where the cycle begins. So at first we have 3 roots, 1, 2, and 3. We look at 1 and 2, and let's say 2 becomes part of 1, and that means that this rank goes up to 2, and 2's root is now 1. So we're pointing at 2 now, right? And we check 1 and 3. 3's root is now 1 as well, so that's set to 1. And 3 is the rank was 1, so now it's going to be 3. So now, because the rank 1 was higher, so with that, we see that we see that 2 and 3 is the parent. Its parent is 1. So then we set. So then that means that these 2 are the items that we want to return, which it is. So hopefully you understand the idea behind it. The idea is to create a tree and find 2 nodes that have the same parent or same root. Yeah. Okay. Because items with the same root, when they have an edge to each other, means that they generate a cycle because it's already connected to the same parent already, or same root. Okay, so we're going to create root, which is going to be 4i in range of the 1 through length of the edges plus 1. So I of I, same item. And what we're going to do for the rank is that it's going to equal 1 for everything. So then what we're going to do is that we have to get all the edges and what we're going to do is union them, like to check if n1 is and n2 is equal to, let's find the parent find root of n1 and find root of n2. And with that, we have found two roots. And if these roots were root 1 equals root 2, then we can return false. If they are else, that means they're equal. They're not equal. That means one has to become the other, like we said earlier, and we should increase the rank. So if rank 1 is greater than or equal to rank 2, that means we're going to set the root of the rank of root 1 to be plus equals the rank of root 2, and we're going to set the root of root 2 to be equal to the root of root 1. Or just R1 in general. But else rank root 2 plus equals root 1 and root 1 is equal to root 2. With that, we have created our tree pointing a tree pointing to the root, and you know that. So we can return true to the item found. But we're not trying to return true or false here. Right. What we're trying to do here is to create a union between these items. So let's put this under a definition called union of n1 and n2. And let's return a boolean. With that, let's return if not union. That means they're equal. They have equal roots. Return well, n1 and n2 as they come in a pair like that, a union. Okay, we also have to move this function up. So one thing to do is that we need to get the find function as well. So we're trying to find the node, like it's find root for a node. So the root is equal to the root of n, while root does not equal root of itself. While the node is not itself, that means there is a parent out there, and so we're going to set the actual root to equal to the root of this particular root, and set r to actual root, and that's going to check its root. So return r. So what that means is, Suppose we have 1 and 1. Of course, they're equal to itself, so that's fine. They'll find each other. So we have root and root for 1 and 2. But when we get to what happens is that this particular this is not the same. So of course, so if look at 2, when we set it to 1, we check 1 and 2, and we set this root to 1, and when we set the roots to 1 and 3, this is 1. We're checking 2 and 3. You see that the root is 1. So what happens is that when we find the root, the 2 is not equal to 1. So we want to find the actual root, and that actual root is 1 here, and we set that as our actual root, and we check if that's the root, the parent, the actual parent, and it is the actual parent because it only points to itself. And that's how we're gonna find the root. We're gonna look at the node that points to itself, and we're gonna keep moving through each node to make sure we get there. So with that, I think we can return the answer now, because we have all the functions, and these functions will go through our process of looking at each, finding the roots and determining which one has the highest rank. One thing is, can't we use the highest rank to help determine, and the lowest rank to help determine where the parent is? Maybe. Oh, so learn something there. Something what we want to try probably is to point this at a int. I don't know if that helps. Probably doesn't. But we know more about what we're doing. Anything else? I think that looks pretty good. Right, the idea where we look at the parent and look at the children with the fewest. Edges? I mean, possibly, since that's our logic. So it would just look for, it would just be a sorting algorithm. So what that means is, it might be slower, but well, let's try it. So this is an idea. I think we are done here, but we're just testing out an idea here. So we're gonna create a list, sort rank dot values dot sort, and that sorts the items of a list. So list. And we're going to return the first 2 items. That doesn't work, because we're only looking at the rank, and we're not returning the key. So we have to do this as a tuple. Okay. We put the value and the rank, and the node here. I think it's items, and we do a rank value dot sort, and then we return the first two ranks. So return rank of value of rank of rank value 0 of 0 and rank value of the node actually is 1. Rank value of 1 and 1. I don't think this will work. And return 1 and 2. Let's print out what rank value is showing. Uh-oh, this video has gone way too long. Hopefully you've gotten what you wanted out of the video already. But looks like we have a rank of 3 for 3. That was unexpected. Wouldn't 3 be the output then? What's going on? What is going on? Okay, that is weird. Okay, this is both interesting and weird at the same time. Let's check this out. Okay. So let's print the rank and the root every single time. So the rank and the root is 2 as expected. The root is now 2 this time. And the rank, the highest ranking item is 3. And the root is 3. What? Yeah. I'm not sure. Actually sure what's going on here. I mean, I guess we could run through the code. This is getting really weird. All right. Especially because 3 is the highest ranking item, as well as like yeah, that doesn't make any sense because this was higher ranking, and compared to the 3, so it should not move to the 3. Like it just shouldn't happen. Yeah. Can't explain it. But from my analysis about what's going on here, it's doing exactly the opposite of what I was expecting it to do, which was having everything point at 1. Right now, everything's pointing at 3 as the parent. And it's just, I don't know. Like, it's not following the logic that I have set out here. It's like, oh, I see. Ha, 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 ha. Very funny. Very funny. I don't even know how that ran properly. Like, that doesn't make any sense. I don't even know how the code ran. But it did. Because they have the same parent. Which is odd find with looking through code, which is always interesting. But looks like I swapped the ranking. But then even though they swapped the ranking, it just ranked them in the opposite direction so that they did have the same parent anyways. So I think there's more analysis to be done. If you have any comments, please comment below. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much and have a good one.